Welcome to my YouTube channel, Chemistry Consult. In this video, I'll be discussing with you the reaction mechanism of the Cannizzaro's reaction. What I've shown you here is the official, what we call the official mechanism as found in literature and highly publicized. So this is the mechanism I would like us to look into and see whether this mechanism is reasonable or not. Two key things to note in this mechanism. The first one is that the rate determining step, this one here, is a bimolecular reaction involving a hydroxide ion and a molecule of aldehyde. So that is the first thing. Then the second thing is this hydride transfer from this species obtained in the from the first reaction to this hydride transfer to the second aldehyde. So that is the second important thing we take note of in this mechanism. Of course, when the hydride is removed from here, this species is oxidized to give us that carboxylate ion, and this species here gains that hydrogen and so is reduced to an alcohol. Now, the transfer of hydride in these circumstances, under these normal circumstances here, is well, a little bit suspicious, because hydride as a living group perhaps is usually possible under catalysis, but in this case we see that these lone pair of electrons here makes this hydride a good living group compared, for example, to the hydroxy group. Okay, so these are the two issues that we have in this mechanism, that it is a second order reaction and in the determining step, and the hydride transfer. Now, to understand what is going on here, let us look at the rate law for the Cannizzaro's reaction. So this is the rate law for Cannizzaro's reaction. So you see that in this rate law, the reaction is second order in the aldehyde and first order in the hydroxide. So in terms of the general interpretation of these rate laws, the rate law tells us the kind of species, the number of species involved in the rate determining step. So if this is the rate law for this reaction, we expect that therefore in the rate determining step we should have two molecules of aldehyde and an ion of hydroxide. So already the mechanism we know for Cannizzaro reaction is different from, contradicts this important fact. So with that problem at hand, what could be perhaps an appropriate mechanism, for suitable mechanism for this reaction? I have with me a proposal that perhaps we may find a bit interesting to look at. So this is the mechanism I'm proposing for the Cannizzaro's reaction. So in this mechanism, you see, according to, in accordance with the rate law, I have two molecules of aldehyde and a hydroxide in the rate determining step. So maybe answering then to that fact from the rate law, then so when this hydroxide attacks here, opens this bond which attacks there and gives us this species, then when we get this species here, in this species, then there is an intramolecular reaction involving hydrogen. So this carbon-hydrogen bond breaks, and these lone pair of electrons attack on this oxygen, breaking this bond which picks up that hydrogen, in an intermolecular reaction, giving us this carboxylate ion and the alcohol. So in this step, unlike in the usual mechanism, we do not have a hydride transfer from between aldehydes, but rather we have an intramolecular reaction which moves the hydrogen from this carbon to that carbon, producing, of course, the acid, okay, and the alcohol.